Yes.
So first, let's start our sessions on databases, SQL Server databases. So first of all, what is mean by database? So the simplest definition of the database is wherever we store the data, we'll call that one as database. Wherever we store the data, we'll call that one as database. So for example, we can store the data in Notepad. So just now I opened one Notepad, right? In Notepads, we can store the data. In Excels, we can store the data. In Notepads, in Excel, in Word document, we can store the data, and even in Notebook also we can store the data, right? So according to the definition of database, wherever we store the data, we are calling that one as database. So we can store the data in Notepad, we can store the data in Excel, we can store the data in Word, in Notebook. Then instead of storing the data in these databases, why we are going with our regular databases like SQL, Oracle, Teradata, DB2, MySQL? Why we are going that with that databases, with these databases? So the main reason why we are going with these databases means security is the main advantage. See, in Notepad, in Excel, you can store huge number of data. I think in per sheet we can store 2 crores of data. In the same way, in our databases, we can store huge number of data, millions of records you can store in these databases. But the security is the main issue if you store the data in these databases. So that is the first advantage why we are going with these databases. And the second one is you can't give access to multi users at the same time. Let's say, for example, this is your Excel sheet, and when you're working on this Excel sheet, nobody can come and work on that same Excel sheet, right? Once you finish the work, after completing your work, another guy can come and he can work on that same Excel sheet. But at the same time, multiple guys can't work on the same sheet. Whereas if you go with our databases like SQL database or Oracle database or DB2 or MySQL, whatever, multiple guys can work at the same time. That's the second advantage. Multi-access is the second advantage of going with this SQL database. I mean SQL or Oracle DB2, MySQL, Teradata or big data. And the third one is limiting, um, giving limited access to the user. Let's say, for example, just think that I'm running my organization in 4 states: Hyderabad, Bangalore, Mumbai, and Chennai. This is my centralized data warehouse. I mean, the complete data, with the complete branches, all branches data I'm storing in one Excel sheet. So, Hyderabad data in the same sheet, Bangalore data, and Chennai data, and Mumbai data. Now, as a Hyderabad manager, which data you need to see now? You don't require that Mumbai information, Bangalore information, and Chennai information, right? You need to only Hyderabad information. As a Bangalore manager, I need only Bangalore information, not Hyderabad, Mumbai, and Chennai. So if you want to give that limited access, you can't provide if you are going with these notepads or Excel or Word or notebooks. So if you grant me the access on Excel sheet, when I open that Excel sheet, I can view the complete data, whatever that is available in that sheet. You can't limit that one, but that limited access you can provide in these databases. You can give access to see only only couple of tables. In your Excel book, you can have a number of sheets, right? So I can't limit the sheets to a user, but I can limit the tables to the user if I'm going with the servers. That is the next advantage. So that's why people are going with these databases. Even though still a lot of people are using these Excels, who are they? Small organization like institutes or small supermarkets, they are using these Excel sheets, but enterprise level they are going with this RDBMS, Relational Database Management Systems. Okay, so a collection of information organized in such a way that a computer program can quickly select the desired pieces of the data. Simply to say, uh, if you store the data, a collection of information stored in an organized manner in row wise and column wise, that is nothing but a database. So wherever we store the data, we are calling that one as database. That is the simplest definition. So the actual technical definition of database is collection of information organized in rows and columns. Stored in columns is nothing but your database. Okay, so database, we are storing data. Now my question is, what kind of data will store in the databases? That is the next part, right? So we are going with the databases to store the data. Now my question is, what kind of data will store in the databases? So what is the definition of the database? Definition of the data, not database, is definition of the data. So if you create a database, that doesn't mean that we can store junk data or unrequired data, right? We have to store only the data which is required for us, required for our organization, which can be used in future. Let's say, for example, my intention is I want to travel from Hyderabad to Bangalore. I don't know which bus or which train will take me to which will go to Bangalore. So what I did is I just asked one guy, so which train will go to Bangalore? So that guy given information saying that some Venkatadri Express from Kachiguda it will go to Bangalore. So I don't know whether that is a correct information or not. When I asked another guy, he said that Venkatadri Express. So I thought that okay, that is the correct information. So what I'll do, I'll just store that information. I'll just remind that information in my mind, and I'll go to Kachiguda. And when I ask the inquiry guys like, I want to go to Bangalore, just give me a ticket for Venkatadri Express. Then that ticket counter guy says that okay, this Venkatadri Express won't go to Bangalore; it will go to Tirupati. So what I'll do? So whatever the data till now you have stored, you have reminded in your mind, is that valid? That is not valid, right? So what you will do immediately? Immediately you will erase the data from your mind and immediately you'll store the information like what the ticket counter guy says like Yeshwantpur Express will go to Bangalore. So I'll store that one in my mind and I'll take a ticket to Yeshwantpur Express and I'll go to Bangalore. So my job ends. So my job is to go to Bangalore. So I went to Bangalore. So after that, is it required to remind that data, remind that information? No, right? So my job is to go to Bangalore. My job is done. So after completing the job, what is the necessary of storing that information? It's useless, right? Then when you store that information in your mind, so when your job is to travel from Hyderabad to Bangalore on a regular basis, in that case, you'll store that information in your mind. So your mind is a database. So what kind of information you are storing in your mind? The data which is valid. So Venkatadri Express, it's not valid. Yeshwantpur Express is valid. And that is related to you. So your job is to go to Bangalore. So you're just storing that information. You're storing the data which is related to you. And when you are storing that information, when you are using that one in future, then only you are storing the data in your mind. So the technical definition of the data is a related fact. Data is a related fact which has future reference value. So data should be valid and it has to relate it to you and you have to use it in future, then only you will store the data in your mind, in your databases. Let's say for example, if you go to a movie, After watching the movie, what we'll do, after watching 2.5 hours movie, we'll chit chat with our friends saying that the movie was good, the hero acting was good, heroine was good, songs were good, cinematography was something like that. We'll do chit chats for 1 hour or 2 hours or half day, mostly, or one day. So after that, do you remember the complete movie? No, right? Why? Because your job, you are is a software engineer. Your job is to remember your tools or your technology, not movies. But just think that one as a movie director. So as a movie director, that information is related to the director. So what he'll do, he'll remember that scenes and all. So that is data. So data is a related fact. So what kind of data you are storing in a database? So the data which is valid and which is related to our organization and which can be used in future, only that data will store in our databases. That is data. Simply to say, let's say here, this is some Airtel database. Okay, this is Airtel database and this is Vodafone. So in Airtel company employees will be there and in Vodafone company employees will be there, right? So to store the information, employees information, I created one table called employee in Airtel databases, and in Vodafone database I created one table called employee. Now Vijay is an employee who is working on Vodafone. Okay, so Vijay is an employee who is working in Vodafone. So where I need to store this information? In Vodafone employee table, I need to store this guy's information. But if I store this Vijay's information in Airtel database, what happens? Vijay is a valid guy. Yes. Vijay is working. Yes. But he is not working with Airtel database, sorry, Airtel company. If I store that guy's information in Airtel database, what this Airtel company will do with that information? So I need to store the information of Vijay in Vodafone databases, then that company can do something. So whatever the data you're storing in the database, the data should be valid. Yes, Vijay is a valid guy. And if it has to relate it to him, yes, Vijay is working in Vodafone, so I'm storing in these databases. And why we are storing? Because we need to use it in future. We have to pay money and we have to check the employee performance. We have to give some increments. We have to see, we have to give some promotions based on his performance. So I need his information in future. So that's why I'm storing this guy's information in our databases. That is the technical definition of data. So data is a related fact which has future reference value. Clear? Now let's discuss about some management systems. So we have two types of management systems. One is DBMS and the second one is RDBMS. So I hope you heard about this DBMS and RDBMS. Database management systems and relational database management systems. So both are used to manage your databases. Then what is the difference between these DBMS and RDBMS? We'll see that one. This DBMS before 80s, there is no concept called RDBMS. So we have only DBMS. This RDBMS was introduced in 80s. Before 80s, we have DBMS. Then what is the difference? So the difference between DBMS and RDBMS is, let's say this is your DBMS. In DBMS, the difference between DBMS and RDBMS, the first one is no relationships can be maintained in DBMS. Don't worry what is these relationships and all. You'll come to know once in further sessions. So what is the relationship and all. When you're going with DBMS, no relationships can be maintained. But if you're going with RDBMS, relationships can be maintained. Relationships can be maintained. That is the first difference between DBMS and RDBMS. So what is mean by relationships? Let me give a brief about this relationship here. Let's say I'm running a company. I started one company. So to run that company, I need employees, right? So to store that employee information, I created one table called employee, and I'm storing that employee information in this table. And employees won't work for free, right? We need to pay salaries. To store their salaries information, I've created one another table called salaries, and in this table I'm maintaining the information, salary information. And 24 by 7 on 365 days employees won't work, right? They'll take some leaves. To store that leave information, I've created one another table called leaves, and in this table I'm maintaining the leaves information. And employees belongs to different departments. So I've created one table called department, and in this department table I'm maintaining different department details, and on which date he got the salary, and on which date um, he has taken the leave. So to maintain the dates information, to have the date information, I've created one another table called date table. So like this I've created 5 tables. Now there is no relationship with between these tables. All tables are acting as individual ones. There is no dependency and there is no relationship. That is DBMS. When you are going with the relational database management systems, relationship is nothing but this salaries table has to relate with employee table, and this leaves table has to relate with employee table, and this department table, this employee table has to relate with department table, and this leaves table has to relate with date table, and this salaries table has to relate with date table. So these kind of relationships will come if you go with RDBMS. Clear? So you'll came to know what kind of relationships are there, like 1:1, 1:m, and m::m. So when we're discussing about some normalization concept, then I'll explain this relationship. As of now, just I'm giving some brief about this DBMS and RDBMS, right? So that's why I just given a brief explanation about these relationships. So that is the first difference between DBMS and RDBMS. Now let's see the second difference between DBMS and RDBMS. So if you are going with DBMS, only one guy can work at the same time. So example for this one is Excel. So Excel is DBMS, and one another database is there, that is AccessDB. So whenever you are install Microsoft Office, if you right click along with this Microsoft Excel, Microsoft Word, you'll find Microsoft Office Access Database. So this is one DBMS database. When you're working on that databases, only one guy can work on the database. Multiple guys can't work on the same database. Whenever, let's say, if I open Excel sheet in a computer, when I'm working on that Excel sheet, no guy can work on that sheet until I close the work. Once I close the work, and another guy can come and sit in front of my computer, and he can open it and he can work on that Excel sheet. So only one guy can work at the same time, that is DBMS. And when you are going with RDBMS, Multiple guys can work at the same time. Multiple guys can work at the same time. So people will say that I'm doing work from home. So how they'll work from home? Their servers will be located in some countries, and they'll connect to that servers using some internet connection, net connectivity. Some using some third-party tools. They'll connect with that servers. Not only one guy, multiple guys can work at the same time. Multiple guys can connect to the same server at the same time. All guys can access the data from the same database. That is RDBMS. So example for this RDBMS is, it's not BT, it's DB. So example for RDBMS is, so the databases which we are using in real time, that is SQL, Oracle, Teradata, DB2, Big Data, MySQL. So like this, you'll have thousands of RDBMS are there in real time. So now onwards, we're going to completely deal with this RDBMS, not with the DBMS, because no organizations are using this DBMS. So enterprise level, everybody are using this RDBMS like SQL servers, Oracle servers, Teradata and all. Clear? So this is about DBMS and RDBMS. Now let's see the next one, that is non-Unicode and Unicode databases. So what is the difference between this non-Unicode and Unicode databases? So now we are going with RDBMS. In RDBMS, you can create the database in two formats. One is in non-Unicode format and the second one is in Unicode format. So what is the difference? So now my question is, what language data, which language data you'll store in a database? Whether English or Telugu or Marathi or Kannada or Bengali or Spanish or Chinese or Japanese. For example, if you take Facebook, so if Facebook guys created their application, and if they store, sorry, if they ask all their users to write comments in only English, because my database accepts only English language, it won't support the remaining languages. What happens to the guys who don't know English? I don't know English. I just know Spanish. If that Facebook guy asks me to write the comments in only Spanish and use that application in only English, he asked me to write the comments in only English and he asked me to use the application in only English application. What happens? I simply avoid that application, right? I won't use it because I don't know English. I just know Spanish. But this Facebook will accept any language data, right? So you'll write one comment in Telugu. I'll write one comment in English. Some another guy writes comment in some Chinese language. So whenever you open your wall, your comments will be shown in Telugu. My comments will be shown in English, and the other guy's comment will be shown in same Chinese, Spanish language. Sorry, Chinese language. How? So whatever the comments we are writing, that comments are storing in the databases only, right? We'll go and store in only database. So that databases are accepting all the languages. So we'll call the databases as Unicode databases. So simply non-Unicode. What is mean by non-Unicode? The difference between non-Unicode and Unicode databases means non-Unicode databases will accept only one language data, depends on the code page. only one language data depends on the code page. So whatever the code page you have defined, like if I define the code page as Telugu, then it will accept only Telugu language. If I give the code page as English, then it will accept only English language. If I give the code page as Spanish, it will accept only Spanish language. That's it. It won't accept the remaining languages data if that is non-Unicode database. If that is Unicode database, it will accept any language data irrespective of the code page, irrespective of the code page. So whatever the code page you have defined, you may give the code page as Telugu, but it will accept all the languages data. Any language, any number of languages data you can insert into that database if that is Unicode database. So non-Unicode databases means language dependent, and Unicode databases means language independent. So that is non-Unicode and Unicode databases. Clear? So non-Unicode database depends on the code page. It will accept the data. It will accept the languages data. The Unicode databases, it is irrespective of the code page. It will accept any languages data. So that is language independent. Non-Unicode. Language independent. That is Unicode databases. So this is about non-Unicode and Unicode databases. So any database, like any server, so whatever the server it may be Oracle server, it may be SQL server, it may be Teradata, whatever the database it may be. So to access the data, so in some language requires, right? So Java is one language where you'll find some classes and objects and all, and .NET is an object where you can find that same classes and all. And the same way, to access the databases, we need one language, right? So to access any database, it may be SQL server, it may be Oracle server, it may be Teradata, DB2, whatever it may be. To access any database, we need one language. So we'll call that language as SQL language, SQL language. That is nothing but structured query language. So this structured query language commonly used in all the databases, not only in one database, not only in SQL Server. Oracle will use the same language, Teradata will use the same language, DB2, all the databases will use the same language, but the difference is there will be some syntax differences will be there. Apart from that, there won't be any difference. So this SQL language is used by the databases. So this structured query language is broadly classified into 4 categories. The first one is DTL. That is nothing but data definition language. So what is meant by this data definition language? In servers, we'll call anything as a database, everything as a database. Object. I'm sorry. It's not database. It's object. We'll call everything as a database. So like database is an object, table is an object, trigger is an object, index is an object, view is an object, stored procedure is an object. Okay, so function is an object. So whenever you want to create any object, we'll go with the keyword called create. So once you create the object, it's not mandatory, like there won't be any modifications, right? There will be some modifications. So after creating the object also we need to modify it. So to modify that object, to alter that object, we'll go with a keyword called alter. So create is the keyword which is used to create an object, and alter is a keyword which is used to alter an object. And after a couple of months or years, mm, the job is done with that object. I created one XYZ table, and that XYZ table's job was done. So what we need to do? We need to delete that one, right? Because if there is no use with the table, why we need to maintain that memory unnecessarily in that servers? It's a waste of space. So we have to delete it. So to drop any object, we'll go with the keyword called drop. And there is one another keyword in DDL, that is truncate. So this truncate is used to delete only the data of an object. Only the data of an object. So these are the four keywords which are in DDL. So data definition language, which is used to create an object, alter an object, and to drop an object. And the next category is DML, that is data manipulation language. So what does it mean by this data manipulation language? With the name, it's pretty clear, right? Data manipulation. So whenever you want to manipulate the data, we'll go with the keywords of DML. Whenever you want to manipulate the existing data, so select, the first one in DML is select. So select is the keyword which is used to retrieve the data from the tables or from the object. I created an object, and insert is a keyword which is used to insert the data into an object. Insert the data into an object, right? So insert is the keyword which is used to insert the data into a table. So after inserting the data into a table, if you want to retrieve the data, we'll go with the keyword called select. So let's say, for example, if you create a table like employee with the structure ID, name, department, and designation. Name of an employee is Vijay, and his designation is ID is 1, his department is IT, and designation is team lead. So to insert that record, we'll go with insert keyword. And after inserting the record, if you want to check whether the data is as properly inserted or not, other you want to check whatever the data that is existing in that table, we'll go with the keyword called select. And after 1 year, that guy got promotion. Before that, now he is team lead, right? Now he got promotion, and he become some project lead. So what you have to do? You have to update that guy's designation. So to update that data, you'll go with the keyword called update. So update is used to update the existing object data. And after 1 year again, that guy resigned to the company. So what we have to do? Simply we have to delete his record from the table. So to delete the data, we'll go with the keyword called delete. So these are the keywords in DML, that is data manipulations, which are used to manipulate the data. And the next one is TCL, transaction control language. So this transaction control language, which is very, very important in database concepts. So this is very advanced one. So we'll see this one in end of the sessions, not in middle or not in first. We'll see this one in end of the sessions. Okay. So first of all, I'll just give a brief explanation about this TCL transaction. So what is mean by a transaction? So always your transaction will start with a keyword called begin. Okay, begin, and think that this is your end statement. End. and in middle of this begin and end, whatever the statements are written, if all these statements are successfully executed, then make the changes permanently to the databases. If any one of the statement fails, then I don't want to save any record. I don't want to save any changes. Let's say, for example, I'm writing some insert statements like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm trying to insert 10 records into a table. So 10 insert statements. If all these 10 insert statements were successfully executed, then store the complete data permanently into the table. If suppose if any one of the statement fails because of any issue, whatever the issue it may be, if any one of the statement fails, I don't want to save any record. That is nothing but a transaction. So either full or null is nothing but a transaction. So when all the statements were successfully executed, then save the changes, commit the changes permanently. If any one of the statement fails because of any issue, I don't want to save any change, any single change I don't want to save in my databases. That is nothing but transaction. So when all the statements were successfully executed, I want to commit the changes. So to commit the changes, we'll go with the keyword called commit. So commit is used to make the changes permanently to the objects server. And if any one of the statement fails, I don't want to save any single change. Whatever the I just want to roll back everything. Roll back. So rollback is used to undo the changes. So these are the two keywords in TCL. And the next category is DCL. Data Control Language. So what is this data control language? So this data control language is completely used by your DBS. Let's say, for example, when you join in a company and your job is to work on some XYZ database. This database. Your job is to work on XYZ databases. So when you got a job, you can't work directly on this database, right? So before you work on this database, first of all, your DBA has to grant the permission on these databases to you. Once you got the permissions, then only you can work on the XYZ database. Until that period, you can't work on the databases. So that permissions will be given by your DBA. So to grant the permissions, he'll use a keyword. Your DBA will use a keyword called grant. So grant is a keyword which is used to grant the permission to the developers. Okay, after granting the permission, you are working on XYZ database. After that, you got a new project that is ABC. Now you are moving from that ABC database to XYZ database to ABC database. Now what DBS will do? He'll grant the permission using grant keyword on ABC database so that you can work on this ABC database. So you are not working on this XYZ databases, right? You are not working with XYZ client. Then why you need permission still on this XYZ database? So what he'll do is using revoke, using a keyword called revoke, he'll revoke the permission. He'll take back the permissions from you. So grant is used to grant the permission on the databases, and revoke is used to take back the permission from the objects. So these are the four categories of structured query language, which are commonly used in any databases, not only in SQL servers. You can use these commands. We'll use these commands in all databases, all different databases, different servers, with some syntax changes. Okay, so this is structured query language.